The question reads, if you begin with 17.9 milliliters of 0.138 molar hydrochloric acid solution and mix it with 15.1 milliliters of 0.119 molar sodium hydroxide, what is the final pH when they are mixed together? And I've given you the balanced reaction. And this is such an important part of this course that not only did we do this previously, but we're doing it this week, and the recitation is about this exact kind of question. What I love about this question is it is a limiting reactant question, as we'll see. It is also a pH question, and so it ties together a lot of the aspects of the class up to this point, and it is a strong bet that something like this will be on your first exam, if not exactly like this. We'll note that this is a reaction between a strong acid, hydrochloric acid, and a strong base, sodium hydroxide. Those are strong acid and strong base neutralization reactions. Those are the only ones that we can do in this course and to determine the pH. So let's go ahead and get started. If it's a limiting reactant problem, you want to find the moles of each reactant. I see that I have 17.9 milliliters. I changed that into liters. That's going to be 0.0179 liters. And then I turn the molarity of HCl. Molarity means moles per liter, 0.138. Moles of HCl per liter or per liter of solution. Either one of those is fine. And calculating this, I get 0.00247 moles of hydrochloric acid. Let's see. Yep. Then I'm going to do the same thing for sodium hydroxide. And actually, I'm going to do something a little differently. So because on the homework, you can get limiting reactants that are either the HCl is the limiting reactant or the sodium hydroxide is the limiting reactant. And I've done an HCl limiting reactant problem before in one of the other tutorial videos. So I'm going to change this problem to, let's change it to something that I know. Let's change it to 30.1 milliliters of 0.119 molar sodium hydroxide solution. So I'm going to make that change, and then that will give you a demonstration of what it's like for a related type of problem. And hopefully with this change, my hydrochloric acid will turn out to be my limiting reactant. So change that there to 30.1 milliliters, where I change the milliliters into liters, and I get 0.0301 liters. And the molarity, 0.119. Molarity is going to be moles of sodium hydroxide per liter of solution. And let's see how many moles I get now. I get 0.0301 times 0.119, and I get 0.00358. Moles of sodium hydroxide. Now, I can't always do this, but for this type of problem I can. So because it's 1-to-1 to 1-to-1 stoichiometry, so, and let's go this, so all coefficients are 1s. So all coefficients are 1s. That means instead of trying to figure out how many moles of product I can make to determine what's my limiting reactant, I can use the moles of reactant. And the reason I can do that is because if I were to determine the moles of, say, H2O that I can make, because all the coefficients are 1s, these would still be the same numbers of moles of H2O that I could make. And then this would be the smaller number. So What I'm trying to say is HCl is my limiting reactant, and I can tell it just from looking at the reactants. Are there any questions about that? Or would you like me to say that again? If not, I'm going to write it right here. HCl is my limiting reactant, and we know that because it's the smaller number of moles, and it would produce the smaller number of moles of product. Then NaOH is excess reactant. I'm trying to write excess there. And I'm going to put a little colon there because once we know that sodium hydroxide is our excess reactant, we know that the final pH in this problem must be greater than 7. And I'll write 7.00 because all pH values have two decimal places in this course, just to remind us of that fact. So let's see. Yes, we're going to have excess sodium hydroxide. The pH has to be greater than 7. Both of these facts are true because we have a basic solution when we're done. Okay, so these two go together. Now, if we were to do stoichiometry to find how many moles of how many moles of our excess reactant, sodium hydroxide, were reacted away, it would be equal to this number. We start with our limiting reactant. We find that it's 1-to-1 coefficients. Therefore, if we did the calculations, we would see that this many moles of NaOH react away. So I'm going to do my next step, which is find the sodium hydroxide left over. And that's going to be my starting amount, 0.00358 moles. I think I'm on screen there, yeah. At start, minus the same number of moles of sodium hydroxide. And those are going to be reacted away. And that will give me my moles of sodium hydroxide left over. And when I type that in, I get 0.00111. And those are my moles of sodium hydroxide left over. Now I revisit my problem statement. It says, what is the final pH? I'm still a couple steps away from that now, but if I know my moles of sodium hydroxide and I know my total volume, I can find my concentration of sodium hydroxide. And square brackets, remember, mean concentration in molarity. It's going to be my moles left over. Divided my total volume, and I'll just make a note here. The number I'm going to write here is my total volume. And my total volume is going to be, and why don't I do this in red? My total volume is the sum of my two volumes that I'm mixing together from up here. So, well, let's just add them up and write them down here. So 0.0179 plus 0.0301, 0.048. And there's really another 0 there. We know that because we always like to keep 3 sig figs. And we can see that the third sig fig just wasn't printed on our calculator because it was a 0. Oh, and that's liters. And then we can divide these two to get our concentration. 0.00111 divided by 0.048. 0.0231. Molarity of sodium hydroxide. And we know that sodium hydroxide is a strong base. We know that sodium hydroxide is also a strong electrolyte. That means it breaks up 100% into ions. And one of those ions is my hydroxide. So we've talked about this before, but now I'm just going to make the jump, though I'm happy to talk about it more if you'd like. So because this is a strong base, my concentration of hydroxide is equal to my concentration of sodium hydroxide, and therefore 0.0231. Okay? And we still haven't gotten to pH yet. This is a long problem. And then from there, there's two possible directions to go. One is to find pOH, and that's typically what I do. pOH is the negative log of the hydroxide ion concentration. It's going to be minus log 0.0231. And 0.0231. On my calculator, I have to enter it first and then hit the log button, and I get 1.64, where I've taken away the minus sign that's on my calculator because there's a minus sign right there. And I also know that pHs are between 0 and 14 in this course, and so pHs, while some calculations can tell you that pH is negative depending upon how things go, you won't find that in this course. In this course, pHs are between, oh, hold on, I'm not done. That's not pH. What am I talking about? That's pOH. I still have one more step. Aha, that's why I always have to go back to my question and see if I've answered it. All right, that's pOH. One more step. So pH plus pOH equals 14.00. I know, and so therefore my pH equals 14.00 minus 1.64. There we go. And now 14 minus 1.64, 12.36. There we go. That's my pH. And my pH is above 7. And that's lovely because that's what I expected. And I think I'm showing all of my calculations right now, although I lost the problem statement in this video. Are there any questions about this?
I wanted to ask, what's the rule that states that the pH is greater than 7? How do you know that the pH will be greater than 7 and less than 7?
Good question, Tamiwa. So we know. So for basic solutions have bases. So pH has to be greater than 7, and the fact that we have sodium hydroxide in excess means that we have a basic solution. We have a base, and we have reacted away all of our acid.
Okay, so if it was an acidic solution, it would be less than 7.
That's right, and meaning that if sodium hydroxide was our limiting reactant and it was gone and we had excess acid, then we would know that the pH is less than 7.
All right, thank you.
Sure, good question. Any other questions? So, then let me just say this. I would expect that on your exam, and no promises, but I would expect that you will get a question in which so a question just like this, and the possibility will be that either HCl is the limiting reactant for some of the possible questions, and sodium hydroxide will be the limiting reactant for the other ones. And so you'll have to be careful on how you do the calculations and make sure that you check in with this step. Say, okay, if sodium hydroxide is left over, then I know my pH is greater than 7. That's a check on your answer to make sure that you've done it correctly. Yeah. Okay. But we'll have lots of practice. That's why one of the reasons we're doing recitation on this today,
Professor,
or this week. Yes.
what if we didn't have like a strong base and it didn't decompose or it didn't go 100%, you know?
Good question. So at this point, the only thing we know how to deal with is strong acids and strong bases. So it's the only thing you'll see. If you're talking about what would happen if you had a weak acid and a weak base, or a weak base, we would see that it's more complicated, and we're not ready for that right now. So the only thing you will see is like the only variations you could see on an exam would be if I gave you a different strong acid like HNO3, nitric acid, or a different strong base like KOH. But they will always be strong acid, strong bases for these kinds of problems, because that's all we can do right now. Okay. Any other questions? Okay.